Hello, ladies and gentlemen, my fellow mathletes. Root Beer here, looking at question 14 on part 1 of our Alberta math contest still. Of the 49 squares of a 7 by 7 square sheet of paper, 2 are to be colored black, while the others remain white. 2 colorings are called distinct if one cannot be obtained from the other by rotating the sheet of paper about its center. The number of distinct colorings is. Okay, so just to clarify what's going on here, I won't use 7 just because that's going to be a little big to write, but just to clarify the concept that they're after. Something like this, which I know has 4 things colored, but this, actually, no, sorry. We'll do something like this. This, if you rotate it on its side, you'll get this and this. So they're saying these two are the same sort of pattern. That's what they're saying. Okay, so that's the idea. We just want to count, but we don't want to count rotations. Okay, and of course, if you rotate again, you would get this and this. So all of these count as 1, and there's, of course, another one, just for the sake of completion. This one. So where you might count 4, you really should only be counting 1. So first, let's count everything on our 7 by 7, every way to fill in 2 of the squares on a 7 by 7 grid, period. Okay? So this time we'll actually draw the big one. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So there we go. We've got 49 squares. We need to choose 2 of them. Now, if you're familiar with choose notation, you might say, 49 choose 2. So 49 factorial over 2 factorial, 47 factorial. But honestly, you don't need to do that sort of stuff to get the answer here. Okay. How many ways are there to just pick 2 dots? Well, you've got 49 choices for your first black square. And then 48 choices for the next one, 49 times 48. However, what if I chose this one first and then this one? So since the order doesn't matter, you just care what you're choosing about. You've counted each possible filling in of 2 black squares twice, so we divide by 2. So it should be 49 times 24. 50 times 24 is 1200, so minus 24, it should be 176. So that's how many ways there are to fill things in. But remember, we're counting some things twice. Or actually, some things are being counted 4 times. Okay? So what we'd like to do is sort of divide by 4 almost. So, you can just divide by 4. You'll get a 19 here, and 11 times 25 is 275. So you add them up, 4, carry the 1, 9, 294. And I bet 294 is a possible answer. There it is. But not everything is counted 4 extra times. Lots of things are, but some things are not. For example, if I did, let's say, this and this, that's the same pattern as if I did this and this, but if you rotate it again, you get back to the original. So you're not counting 4 distinct things as 1, you're counting just 2 distinct things as 1. Okay? So some of these have sort of a 180-degree rotational sort of symmetry. They're the same when you rotate them twice. Now, nothing will be the same when you rotate it 4 times, because as soon as I place 1 black square, I would need that same black square in 3 other spots. I've only got 2 black squares. But it is possible when I put this black square in to rotate and fill this one in. And then you only have 2 distinct things coming from this pattern. Because if you keep rotating, you get copies that you've already gotten before. So now the question is, well, how many of these are there? I'd like to be able to divide by 4, but some of these things are only counting for 2 things at once. Well, how many of those are there? Well, imagine this. If I fill in any square in the top, you would just fill in the corresponding square in the bottom. Right? So if I fill this in, fill this down here, and then you have one of those things that is the same when you rotate it 180 degrees. Those are the things we're now trying to count. Now, what about this little sort of side piece? Well, if you fill in something in here, you would just fill in the corresponding thing over here. And of course, nothing can go in the center if you're going to be able to be the same thing when you rotate by 180 degrees, because, well, if you fill in the center, where's your other black square going to go? You put it here, then it's not the same when you rotate it 180 degrees, because then this square should be here. Well, it's not. So the center has to remain empty. And then we have 21 plus 3, 24 squares to choose from. So there are 24 sort of patterns that only get counted twice. Okay. So of these 176, subtract 24, you'll get 152. And these are patterns that are counted 4 times, so we'll divide by 4. And so you get 275 plus 13. That'll be 288. So these are the patterns that are counted 4 times. So that's me saying, these 4 are the same, just count one of them. And then there are 24 patterns that are counted twice here. So 24, the divide by 2, because you can only rotate them the one time. So that'll be 12. So counted twice. So add them up and we get 300. And there we go. So 300 is D. And there we go. So that's the answer to question number 14, was it? Yeah, question number 14. We've only got 2 more to go, so join me for question number 15, if you dare. No, it'll be fine. Join me for question 15 next time, and have yourself a wonderful, wonderful day.